All right, today we're looking at number 23 on the homework. We have a question that says a block accelerates at 3 meters per second squared down a plane inclined at 25 degrees. And it wants us to find mu k between the block and the inclined plane. And it tells us that the acceleration due to gravity is 9.81 meters per second squared. Of course, your numbers will vary, but it'll all work out for you at the end. All right. And so at this point, we've got our block drawn. We've got sort of the startings of our free body diagram, and we're going to add to that. So I'm going to take, and first thing I'm going to do is add the force due to gravity, the weight of the block, and we'll break that into components in just a minute. Remember that we're going to be using our alternate axes since it's moving along an angled surface. We're going to angle our axes so that we've got our XY axis angled and tilted like that. All right, so there's our force due to gravity, or the weight of the box, Fg, and we'll be splitting that into components in just a moment. Now, since that's pushing against the ramp also will be pushing back with a normal force, and that'll be perpendicular to the ramp. And since they ask us for mu k, force due to friction is going to be acting up the ramp. And I'm going to label Ff, which is acting up the slope, and Fn, which is provided by the slope, and it's perpendicular to the surface. All right, so we've got those. Now let's go ahead and draw in the components of Fgx. I'm going to put those in as dashed, or excuse me, the components of Fg. So there's going to be Fgy, and there's going to be Fgx. Again, remember that we're using our alternate axis. Okay, and I'll label those Fgy and Fgx. And remember that theta, this angle theta, happens to have the same measurement as the angle between Fg and Fgy. All right. So at this point, what we'll do is we'll write equations about what is equal to what. Now you remember that it's accelerating down the ramp, which means there's a net force down the ramp. In other words, Fgx is larger than Ff, and so the difference between those two, Fgx minus Ff, is equal to F net. All right, so there's our equation for our x dimension. Now, if we look in the y dimension, there is no acceleration, and so that just means that Fn will be equal to Fgy. Excellent. All right. Now, we always know that F net is equal to m times a, and we also always know that Fg is equal to m times g. All right, good. Now at this point, and of course our finishing idea is going to be the thought that mu is equal to Ff divided by Fn, because that's what we're actually asked for, mu, and so we'll end up needing that little idea toward the end. All right, at this point you say, okay, I'm going to need Ff and Fn. Well, Fn is equal to Fgy, so we just need to break that apart and get values. Well, we'll need the value of Fg, and you'll find that from m times g. And at that point you realize that you do not have a value for m, and so you will not be able to get a numerical value for any of these. Okay, that would seem to be quite the problem. However, all is not lost. What we're going to do instead is we're just going to work with the letters and see what happens. All right, and so Fgy is actually equal to Fg times cosine, because it's the adjacent side, times cosine times theta. Now remember, Fg is equal to m times g, so I'm going to rewrite this, that Fgy is equal to m times g times cosine theta. All right, and Fg, I'm going to underline that so I can find it later when I need it. And Fg x is actually going to be equal to f times g, fg times sine theta. In other words, fgx equals m times g times sine theta, and underline it for convenient finding shortly. All right, well, I'm going to start looking at this. Mu is equal to ff divided by fn. Now, fn is equal to fgy. So in place of fn, I'm just going to go ahead and put fgy. In other words, since fn equals mg cosine theta, I'll substitute that for this term, m times g times cosine theta. Now, ff, we'll need to solve for that. Let's see. So what I'll do is I'll swing ff around to this side. Fgx equals f net plus ff. And at this point, then, we'll subtract f net from both sides. And so fgx minus f net equals ff. And so now that I've solved for ff in terms of this, let's substitute our equations earlier. Fgx is m times g times sine theta minus, and f net is ma. So that minus ma equals ff. So I'm going to put this whole set of letters, that whole term, in place of ff. So right here, m times g times sine theta minus m times a. And of course, remember that m times g times cosine theta is actually under each of those terms, because of the way that we handle denominators with split numerators. All right, and so at this point, what we can see is that the mass is actually present in all three terms, and so you are able to divide it away. And so then if you'll simplify that, you will end up with mu equaling, so as you clean that back up, you'll end up with mu equaling g sine theta minus a divided by g cosine theta. And at that point, you actually have values for g, it's 9.81, theta, and a. And so you'll be able to put your numbers in there and get a solution for mu. And that is how you solve. When you don't seem to have enough numbers to solve numerically, start solving with letters. Start solving algebraically and see what happens. And very often, as you come to the end, something will divide away, and you'll be able to find a solution. All right, I hope that was helpful, and have a good day.